Good morning, champs. Why is the gradient always perpendicular to level curves? This is one of the most important geometric facts in multivariable calculus. Let's prove it step by step. A level curve means the function stays constant. So if you move along that curve, the function value does not change. At the same time, the gradient points in the direction of steepest increase. So intuitively, moving along the curve should be perpendicular to the gradient. Now let's show this rigorously. Let f of xy be a differentiable function. We look at a level curve defined by f of xy equals a constant c. This means all points on the curve have the same function value. Now we describe this curve using a parameter. We write gamma of t equals x of t, y of t. So as t changes, we move along the curve. Because the curve lies on the level set, we have f of x of t, y of t, equals c for all t. Now we differentiate both sides with respect to t. On the right-hand side, c is constant, so its derivative is 0. So we get the derivative with respect to t of f of x of t, y of t, equals 0. Now we compute the left-hand side. The function depends on x and y, and both depend on t. So we apply the chain rule. Step by step, this gives partial f with respect to x times x prime of t plus partial f with respect to y times y prime of t. So the equation becomes f sub x times x prime plus f sub y times y prime equals 0. Now this expression has a structure we can recognize. We define the gradient as gradient f equals f sub x, f sub y. And the tangent vector to the curve is gamma prime of t equals x prime of t, y prime of t. If we look at the equation again, we multiply corresponding components and add them. That is exactly a dot product. So we can rewrite the equation as gradient f dot gamma prime of t equals 0. Now here is the key conclusion. The dot product of two vectors is 0 if and only if they are perpendicular. So the gradient is perpendicular to the tangent vector. And since the tangent vector lies along the curve, this means the gradient is perpendicular to the level curve. Geometrically, this makes sense. Moving along the level curve does not change the function, so that direction has no increase. The gradient points in the direction of maximum increase, so it must point at a right angle to the curve. Quick recap. We described the level curve using a parameter, differentiated the constant condition, applied the chain rule step by step, rewrote the result as a dot product, and concluded that the gradient is perpendicular to the curve.